A very good evening, friends. So last time, I think 16th of June we met somewhere, right? Somewhere in the middle of the class, we happened to, right, discontinue because of my, right, the health condition then. Okay. So today, somewhere we'll continue from where exactly we have left it. Okay. So last time when we met, my dear friend, somewhere around 7, 8 questions we have taken as a task, right? Uh, Somewhere, as I told you, right? The salient features of world physical geography is that part of the syllabus what I'm just somewhere concentrate, right? Having said that, when I talk about, say, for example, this Indian Ocean dipole, how exactly it reduces the impact of El Nino on Indian monsoon, somewhere, right? Last class itself we have discussed. Okay, see, El Nino, somewhere I understand it has a negative impact on Indian monsoon because I understand the southwest monsoon which comes to India actually, say for example, they have their indirect source from what? Peruvian coast. From the Peruvian coast they come. Am I right? Indirect source. Okay. For the southwest monsoon to be very strong, I said the southeastern trade of Indian Ocean should be strong, and eventually the southeastern trade of Pacific Ocean should be strong. El Nino will affect southeastern trade of Pacific Ocean, but Indian Ocean dipole, the two particularly, right, positive phase, my dear friends. Positive phase somewhere will be somewhere resulting in having a very strong southeastern trade of Indian Ocean. Am I right? So one is favorable, another is unfavorable. So somewhere you have a compensating effect. Last class we discussed about the same. Correct? Okay. And in between, my dear friends, just a piece of information, right? Say for example, June 16th, right? Already geography optional subject has been started, right? Say for example, Prish Sengar Singh will be handling geography optional subject. He has a vast experience of 11 years. Kindly make use of it if you are in need of it, right? Especially for the students of Unacademy platform. Okay. And as you know that we have a foundation batch starting somewhere in June 22nd, that is tomorrow, right? 1 year completely, this batch is dedicated for GS, and the target is for UPSC 2024, which aims at covering 100% of the syllabus. Again, right? Somewhere if you feel that it is useful, kindly make use of it. Okay. Right, my friends. Now, coming back to this continental drift theory, if I am not wrong, somewhere this question also we have discussed in the last class. Okay, last class we have discussed. Critically evaluate continental drift theory. See, 2013, this question already they have asked, but only thing is that this word critically evaluate, they have not asked. Okay. Somewhere they said, what do you understand by continental drift? Bring out the evidence in support of it. When I say critically evaluate, both the positives and negatives I have to talk about. But let me tell you, any question you conclude, always conclude on a positive light. Am I right? Always conclude on a positive light. Because see, I should understand somewhere there is a relevance of this theory in the subject. That's the reason you have the subject in this. Say for example, say for this theory you have, say for example, you have, right, right, as such, theory as such, you have it in any subject as such. Okay, so always try to conclude in the positive light. Why I'm skipping it? Because last class, right, that half-an-hour session, somewhere we have completed that. Okay, right, my dear friends, I'm just venturing into the third topic, right? And one more thing, see, kindly understand, there is no one way of answering a question in mains examination. There are n number of ways, but only thing is that I have to understand what exactly is the crux. Somewhere try to revolve around the crux itself, and of course, I have to somewhere justify what exactly the question is eventually asking about. It is, say, for example, it is asking about. Finally, ultimately, it is asking about. Okay, right. Now, here again. Any question you take it, kindly see that how many questions are lying within a same question. Okay, for example, here explicitly they have mentioned. What do you understand by air mass? That is one question. How does air mass influence the climate is second question. It means I have two, say for example, separate question itself I have asked it. Rationally, you can award, say for example, somewhere allot how many words you're going to write it. Okay. What do you understand by air mass? You can allot somewhere, say for example, right? If at all, assume that, say for example, if it is 150 words, somewhere a definition, anywhere between 50 to 60 words, somewhere I can devote it for, say for example, defining or briefly explaining. Briefly explain itself is an oxymoron, but still I'm using this word. Briefly explaining this air mass, I can take somewhere around 50 to 60 words. Okay. How does air mass influence the climate? Maybe the remaining words, nearly 100 words, I can use it. If it is for 250 marks, yes, I can write plenty about it. Okay. Right. So the first part, my dear friends, I have to understand what do you understand by air mass. Very simple. Three-dimensional, right? Right. Define it. Three-dimensional homogeneous mixture of air. When I say three-dimensional homogeneous mixture of air, somewhere when I talk about homogeneity comes the question, homogeneity in what? Right, in two aspects. Homogeneity in number one, temperature. Homogeneity in number two, humidity or moisture. Right, both, either of it you can do. Either you call them as moisture or you call them as what, humidity. Correct? Right. So this is what there is a homogeneity. See, air mass size can be, say, for example, wherever the homogeneity extent, that can be the size of an air mass. Okay. So, what is an air mass? I have to define it. So, somewhere I should say, right, somewhere, see, definition. What is a definition of a definition, if you ask me? Use minimum number of words to give a gist of a concept. That is what the definition is all about. Okay. Right. So, having said this, right, right. When I talk about air mass, what exactly is an air mass? Somewhere I'm defining it. Three-dimensional homogeneous mixture of an air in terms of temperature and moisture. Right. Okay, I have defined it. Okay. So post definition, right? Now I have to understand that how exactly air mass get developed. Air mass, say for mass of an air, as simple as this. I mean, three-dimensional homogeneous mixture, right? Fine. Right. So this air mass normally gets developed, my dear friends, if this air mass is placed over any place for a longer time. Technically, we say it gets developed under a stable condition. Right? Neither a horizontal movement is there nor a vertical movement is there. Right? If this air mass or this mass of an air is placed over a particular place over a period of time, the air mass will get developed. And now comes the question, right? What will be the character of this air mass? Very simple. Whatever is the character of that particular place will eventually become the character of this air mass. For example, if this air mass is land, this air mass will be dry. Or sorry, if this place is land, this air mass will be dry. If this place where exactly the air mass is getting developed, if it is a water body, this air mass will become wet. If this place where exactly air mass is getting developed, if it is somewhere located on a lower latitude, right, the air mass will become warm. Somewhere if it is getting developed in higher latitude, the air mass will become cold. So where exactly the air mass gets developed, accordingly, right, the character of the air mass is determined. So in that way, my dear friends, simple, right? What is an air mass? Somewhere we have defined it. Now comes the question, if it is 250 words, you can also talk about types of air masses. Types of air masses. Okay. What are the different types? Very simple. I'm just talking about the all the combinations, right? Right. All the combinations. For example, I said, whenever I just talk about, say, for example, depending upon the temperature, either I can have an air mass, say, for example, this air mass can be warm or it can be cold, right? Either it can be warm or it can be cold. Correct? I can also classify this air mass based on moisture content. Am I right? Based on moisture content, my dear friends, this air mass can either be dry or it can be, say, for example, wet. Right? If it is developing in the land, it will be dry. If it is getting developed in the water, it will be wet. Correct? Marit. If it is developing in lower latitude, am I right? Lower latitude, or say, for example, even during the summer season, it will be warm. If it is developing in higher latitude, right? I'll use the symbol higher latitude, or say, for example, winter, this air mass will be cold. Okay, as simple as this. How air mass gets developed, I know, right? Now, my dear friends, warm air mass, generally we use it, say, for example, right? What is the symbol you use it if you ask me? For example, warm air mass, we use a symbol called as T, capital T. Capital T means tropical. It means tropical air mass. C, when I talk about cold, higher latitude, right? I may use this alphabet called as P. P means polar air mass. Okay. Dry means, right? I'll be using a small c called as C, continental air mass. Continental air mass. Okay. Wet means I'll be using the small, say for example, alphabet like M. M means maritime air mass. Maritime, correct? Marine influence of. So, based on the temperature, either air mass can be tropical or polar. Based on the moisture, air mass can be either continental or maritime. Am I right? Right? Continental or maritime. Now, if I say, for example, take the, say, for example, combination, right, of it, very simple, right? Again, what is a combination? Based on temperature, right? Based on temperature. I have what? Either it can be continental, sorry, excuse me, it can be tropical or it can be polar. Based on moisture, it's just not question. I'm also including the concepts in it. Am I right? If it is a moisture, either it can be continental or maritime. So I have to go of a combination, right? For example, my air mass can be continental tropical. My air mass can be continental polar. My air mass can be maritime tropical. My air mass can be maritime polar. Okay, right. So continental tropical means, right, it is, say for example, warm and dry. They are warm and dry. Correct? Continental polar means cold and dry. Maritime tropical means, say for example, it is, right, warm and wet. Maritime polar means, say for example, it is cold and wet. All combination we have taken it. Okay. Now see, air mass itself is a very important concept. Somewhere, say for example, if I just talk about the monsoon, technically speaking, monsoon, we say monsoon is the time. Southwest monsoon is all about influence of which air mass. If you ask me, it is maritime tropical. It is warm and wet. It is warm and wet. It is maritime tropical. This is the air mass which influence this. Say for example, right, monsoon. Okay. When talk about, say, for example, you would have heard about somewhere cold Siberian polar wind somewhere, say, for example, right, in Asia, we have winds like Purgas. That is nothing but what? Cold and dry winds. Blizzard is a cold and dry winds. You would have heard about, say, for example, temperate cyclones. When exactly temperate cyclones gets developed, if you ask me, temperate cyclones normally gets developed when, say, for example, warm and dry, okay, or maritime tropical, warm and wet air mass comes into contact with cold and dry air mass. This is a time there is a chance that temperate cyclones will get developed. So air mass is a very important concept. Okay, right. So somewhere I have also talked about the, say for example, concept, right? So explaining the concept is not needed in the examination. What is an air mass? You define it. What are the types of an air mass? What are the combination? First part of the question is over. How does air mass influence the climate? You can write it. How? Very simple. If continental tropical air mass is influencing a particular place, this, say for example, wherever the place, right? Say for example, that place will become warm, this place will become dry. For example, you would have heard about that warm and dry winds coming from desert regions, that too during summers. India also we have one such wind, Lu. Lu is nothing but what? Continental tropical wind, right? Continental tropical air mass. Okay, it'll be warm, it'll be dry. You'd have heard about blizzards, right? I told blizzards is nothing but what? Cold and dry winds, right? Blizzards, purgas, right? Pamperos, bursters, right? Even say, for example, for that Fohan, plenty of winds. They are cold and dry winds. I said monsoon is a classical example of maritime tropical. During cyclones, what you experience is what? Maritime tropical. Okay, right. So somewhere, right, the second part of the question, right, maritime polar is actually a theoretical wind. Okay, but rest of the three I can somewhere always I can take it. Okay, right. So somewhere, my dear friends, whichever air mass influence a particular place, that place will experience, or somewhere it will be somewhere experiencing the effect of this air mass. The air mass is cold, the place will also comparatively the temperature will come down. The air mass is wet, the place will start getting precipitation. That's what I have to explain it. Okay. So this third part, the third question, I'm confident that you can manage it. Okay, right. I also said, right, how exactly precipitation and temperature of a particular place is determined. Okay, and number of examples also I have just given it. Cyclones also I have just given, right? Right, my dear friends. Now, question number 4. Again, say for example, a direct question. Give an account of favorable. See the word is, this is very important, right? Favorable local winds of world and India, right? So whichever word limit it is asked, right? Assume that this is asked for 250 words. Kindly ensure that you somewhere divide it. See, they have not asked you that how many words you have to write it for world and India. But I feel, right? I feel that it is better that you say, for example, divide 50-50, right? Say, for example, approximately 125 words for the local winds. That too, not all local winds, right? You have to ensure that favorable winds, right? Favorable winds, okay, of world, and say, for example, half the answer you can devote it for what? The favorable winds of India. Okay. For that case, my dear friends, how to start this answer if you ask me, right? For example, if it is 250 words, I can give definition. 150 words, directly you shoot the bullseye. Okay, right. In that way, right, what we understand. For example, here, first define local winds. What exactly is a local wind? Right? You can say that it is a gradient wind, right? Say, for example, which is influenced by the, say, for example, almost the pressure difference of a local place or a very small geographical location, right? Okay. And once I talk about this local winds, my dear friends, right? Though I said name different types of local winds, only thing is that I have to talk about the favorable local winds as such. Okay. So just say, for example, just mention what exactly is a local winds. Local winds are very small area winds. Very small area winds, right? Sometimes you also call them as what? A local gradient wind. Gradient is the sense. Normally, this pressure gradient force, we call them as what? A wind which is created by pressure gradient force. Local pressure difference, you call them as what? Gradient wind. Okay. Having said this, okay, what are the favorable winds? I'll just tell you, right? See, for example, here, not necessarily that all the favorable winds you should take it. Okay. For example, if that is the case, right, go by nicknames, my difference. For example, you would have heard about this word, very famous wind called as Chinook. Okay. See, if you follow some order somewhere, you can say, for example, write more of such answers. In that way, when talk about the local winds, my difference, local winds, favorable local winds, right? There are universal winds. Universal in the sense, wherever I have a coastal area and wherever I have a mountains, I have this land breeze and sea breeze. Correct. Instead of mentioning, you can say that land breeze and sea breeze, right, has its own, say, for example, favorable condition. Right. If you want to explain it, you can explain it. Otherwise, mountain breeze and valley breeze. Mountain breeze and valley breeze plays a very, very important role in maintaining the temperature difference between mountain and valley. In maintaining, say, for example, almost facilitating, say, for example, the farming along the mountain slopes also, it does. Okay. But this question, I feel that you should be more specific. Take the names of the local wind. In that way, right? First, when I talk about, say, for example, some of the descending winds of the world, you'll be having the mountains of the world, right? Along the mountains, I'll be having descending winds of the world, right? Descending winds will be normally warm and dry. Because if I have a mountain, if a wind is rising using the slope of the mountain, right? If it is rising using the slope of the mountain, this wind will become, right? Say, for example, it will become cold, it will become wet. Okay. Adiabatic lapse rate. Or if not adiabatic lapse rate, at least I have this normal lapse rate, right? Once the air mass rises, it becomes cold, 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 and colder. How it becomes wet? Because relative humidity will increase. Carrying capacity will decrease, so the relative humidity will increase. But we are talking about what? Descending wind. So the descending wind will become warm and the descending wind will become what? Dry. Now you may wonder, what is this warm and dry winds? You are calling it as what? Favorable wind. Very simple. Cold winds in warm areas and warm wind in cold areas will be favorable. Dry winds in wetter location and moist wind in dry locations will be favorable. Okay, in that order, my dear friends, one very important wind, you have this wind called as Chinook. Chinook, you call them as a snow eater. Okay, Chinook has a very big advantage, right? So when I talk about, say, for example, Chinook, we call them as a snow eater, right? Let me tell you, it will be somewhere melting the snow away, right? Because say, for example, the leeward side of these Rocky Mountains, you have a grassland, extensive grassland called as prairies, steppes of North America. You call them as what? Prairies. So the grassland, as the warm and dry winds somewhere have its effectivity in the grasslands, the snow will be melted away. Once the snow melts away, the grasses will get exposed, right? Of course, it can be used for grazing. Cattle gets benefited. Dairy industries gets benefited. Horticulture gets benefited. It checks that, say, for example, right, plants, crops do not, right, experience the condition of frost. Vineyard cultivation gets, say, for example, benefited. So plenty of benefits you have, right, pertaining to what? Say, for example, this. Okay, Chinook as a wind. Okay, I can talk about Chinook. Okay, number one. Okay. Number two, I can talk about, say, for example, even Fogen. Fogen, Alps. Okay, right? I can talk about, say, for example, Fogen, right? Fogen, okay. Or if not, okay, right. It's more of Alps, I can talk about Fogen, right? On the other hand, my dear friend, say, for example, you'd have heard about another wind. I'll give you another wind. Again, it's a favorable wind, right? When talk about favorable wind, you have a wind called as Harmattan. Harmattan, sometimes you come across this Harmattan is called as dust devils. Dust devils. Before going to Harmattan, as I said, Fohan as a wind. See, Fohan as a wind is a beneficial. Chinook, I have just given it, right? Fohan also belongs to the same, right? Say, for example, category of Chinook. Okay, right? Say, for example, they are hot winds. Whatever Chinook does in USA and Canada, Fohan does in what? Alpine Cordillera. Okay, right. Then say, for example, right? I'll come for this, right? This Fremantle Doctor, say for example, this is a wind in Australia, but before that, I'll give you one more name. You call them as what? Harmattan. Where exactly Harmattan flows, if you ask me, right? This is the place, my friends. Harmattan flows here. Okay, Harmattan. Harmattan. Harmattan, sometimes you call them as a dust devil. Dust devil, right? It means it carries lot of aerosols along with it, right? They carry something like Loo of India, right? Loo of India, it carries that sand particles from the desert. You call them as a dust devil. In spite of calling this as a dust devil, my dear friends, Harmattan is a favorable wind, right? Because if you ask me what exactly is the nickname of Harmattan, Harmattan is called as a doctor wind. You call them as a doctor wind. Why exactly you call it as a doctor wind? I tell you because see, summers area of its effectivity will be Gulf of Guinea. Gulf of Guinea region will be experiencing hot and humid climatic condition, right? When you experience hot and humid climatic condition, when this dust wind carries a lot of aerosol comes in, it will reduce the temperature. Aerosol will act as hygroscopic nuclei. Simple. Put it very simple, right? Somewhere it will be resulting in ready condensation and precipitation. So this Harmattan brings a welcome precipitation. Welcome precipitation means much needed precipitation, right? You're expecting a precipitation. If it comes, you call them as what? Much needed precipitation, right? Something like that. Okay. So I can talk about Chinook. I can talk about Fohan. I can talk about Harmattan and some of the other, right? When I talk about Fremantle Doctor, it's also beneficial bit. I'm just reading it for you. Fremantle Doctor, sometimes you also call them as what? Right? This Frio Doctor or simply the Doctor. Okay, simply the Doctor. That's how it is addressed in, right, Australia, right? The vernacular language. So there's a term for cooling, right? Afternoon sea breeze. Sea breeze means a breeze which comes from the sea, which occurs during the summer month in southwestern coastal areas of, right, Western Australia. Okay. So summer, see for example, whenever during summers, if you have a sea breeze, my dear friends, that is beneficial. Okay. Then coming to India. India, most of the local winds, my dear friends, they are named after plantation crops. Plantation crops. Why I'll tell you? Because if you ask me when exactly is the season of local winds in India, the season just comes before summer. I have something called as dry summer as a period. Dry summer as a period. Just a season which comes before monsoon. That's the reason the local showers in India, sometimes we also refer it as what? Pre-monsoonal showers. During the dry summers as a period, we'll be having it. Okay. Now see, name itself says, the season itself, we say dry summer. Summer longer days, temperature is also high, right? Temperature is high. On the other side, say for example, when I talk about condition, dry condition, am I right? The moisture is also less. So normally the plantation crop will be somewhere facing a threat. Okay. So sometimes, if that is the case, my dear friends, if some local showers, local wind brings precipitation to those plantation crops, it will be a beneficial wind. That's the reason most of the local winds in India, they are named after the plantation crops, which gets benefited out of it. In that way, I have mango showers. Obviously, I understand it benefits the mango plantation. Am I right? Particularly the west coast, my dear friends, Karnataka, Kerala, right? The Konkan coast, including the Goa and parts of Tamil Nadu, west coast, right? It helps in ripening of mangoes. Number two, cherry blossom, right? You might wonder, right? What is cherry blossom? Do we have cherry here in India? If you ask me, cherry blossom is a beneficial wind for coffee plantation, right? It is for coffee plantation, right? Coffee plantation, right? It's a beneficial. Why it's coffee plantation? You use this word called as cherry blossom means this coffee bean is there, right? This coffee bean, when it ripens, it looks like a bunch of cherry. It looks like a bunch of cherry, right? So that's the reason somewhere it brings that welcome precipitation for coffee plantation. So by the time I use this word called as coffee, I am there in Karnataka, and I can also include what? Kerala. So Kerala and Karnataka are the two places which is known for what? Coffee plantation as such. Okay, right, my dear friends. Then of course we have this Bardoli Chira, right? Bardoli Chira. See, Bardoli Chira beneficial. Sometimes you also call them as what nor'wester, right? Bardoli Chira, Kalbaisaki. Actually speaking, Kalbaisaki is slightly a kind of a cyclonic precipitation in West Bengal. But the same Bardoli Chira, if you experience in Assam and sub-Himalayan West Bengal, that is Darjeeling Hills, it becomes bit beneficial. Okay. In Assam, though it is cyclonic circulation, it benefits this rice and jute cultivation there. Okay. What is not given here, if you want me to add one more wind, which is very closely associated with Bardoli Chira, if you ask me, you would have heard about this wind called as tea showers. If coffee showers are there, I can also have tea showers. See, these tea showers, Bardoli Chira, Kal Baisakhi, they are very much related. There are theories saying that Kal Baisakhi weakens itself to become what? Tea showers. That's what the idea is. Okay? Right. Right, my dear friend. So, beneficial winds. Only the beneficial winds I am just taking it. Okay? Right. Moving on to one more question. Analyze the oceanic features in the light of plate tectonics. See, this theory, right? Plate tectonic theory. Plate tectonic theory. Once in, say, for example, right, 2 years once, 2 years once, on an average, once in 2 years you experience or you expect, say, for example, at least we have one question which is asked from this plate tectonic theory. Only very rarely, only once they have directly used this word called as plate tectonic. Otherwise, they don't directly use this word called as plate tectonic. Now, see, understand. Analyze the oceanic features in the light of plate tectonic. What is plate tectonic? Plate tectonic theory, somewhere it talks about the movement of plates, plate movement. Plate tectonic theory is based on the principle that lithosphere is floating over asthenosphere and eventually somewhere drifting under the influence of convective magma currents. Okay. So in that place, in that time, my dear friends, what I have to do? Briefly explain oxymoron. Okay. Okay, whatever it is, okay, somewhere, right? I have to talk about plate tectonic theory and how oceanic features are associated with plate tectonic theory. Okay, I'll tell you this way, right? Somewhere you say that how what is this plate tectonic theory? What plate tectonic theory aims at? Plate tectonic theory somewhere helps us in understanding the locational aspect of plate boundaries. Because plate boundaries are the place where I have tectonic forces, endogenic forces. Okay. All that variability development will be taking along this plate boundary as such. Okay. Now the question, talks about oceanic features in the light of plate tectonics. Simple, very simple. I have to talk about oceanic features that is located along the plate boundaries, right? I have to somewhere, right? I have to discuss about the oceanic features. Of course, I'm going to talk about active tectonic plate boundaries. So there are three types of plate boundaries. What are the three types of plate boundaries? Convergent, divergent, and transform. In oceans, transform boundary and divergent boundary behaves more or less similar, but though they are slightly different from each other. Convergent means name itself says two plates moving towards each other. They are converging. Am I right? Two plates moving away from each other. They are diverging. Two plates slide past each other. Transform somewhere. It is going for what? Kind of making a transform boundary. Okay, right. So right, my dear friends, in that way, right, right. When I talk about, say, for example, this plate tectonic theory, somewhere, as I said, you're going to talk about this plate boundary of the ocean. I'm not talking about plate boundaries of the land. I'm not talking about Himalayas. I'm not talking about, say, for example, right, right. Maybe the block mountains and fold mountains as such. I'm going to talk about the boundaries of the ocean. Now I'll talk about convergent boundary. Okay, right. When I talk about convergent boundary, my dear friends, what all I'll be having? Wherever I have a convergent boundary in the ocean, what I'll be having is deep oceanic trenches. Because I know oceanic crust is heavier. Whether this oceanic crust goes for a convergence with another oceanic crust or, say, for example, continental crust, right? Either of them will be going for subduction. The visible zone of subduction, you call them as what? Oceanic trenches. Okay, right? Trenches. So somewhere I have to talk about the trench formation. Give some examples. Right? Give some examples. Nazca Plate converging with the South American plate. The world's longest trench is resulted. Chile Peru Trench. Philippine Trench and Pacific Plate going for, say, for example, this diagram I have not given, but okay, if at all, if you're going for it, right? Philippine Plate and Pacific Plate going for a convergence has created the deepest trench of the world called as Marianas Trench. All sides of Pacific Ocean is an example where oceanic crust or somewhere oceanic crust is going for what? Convergence with continental crust. That all sides of Pacific Ocean, very popularly we call them as what? Circum-Pacific Belt, or very popularly even it is called as what? Pacific Ring of Fire. And again, if you ask me Ring of Fire, what exactly Ring of Fire is known for? Not only volcano, it is also known for what? Trenches. Okay, trenches. And my dear friends, subduction do not stops there. Am I right? Subduction will lead to destruction. Destruction will be somewhere resulting in what? Volcanic activity. And this volcanic activity can result in making an island arc. Mostly this island arc is because of the upliftment of magma, most of the time. Okay. So two features. Wherever I have a convergent boundary in the ocean, what is that I find? I find trench, I find islands. Over? Okay. So convergent boundary feature is over. Now coming to the divergent boundary. If you're there in the divergent boundary, my dear friends, what is the default feature? I'll be having mid-oceanic ridge. South American plate, Atlantic Ocean itself is a rift valley. So the middle of Rift Valley, what I find is a mid-oceanic ridge, very popularly called as what? Mid-Atlantic ridge. Right? It is called as mid-Atlantic ridge. Okay? Right. Somewhere I have to talk about the formation of this, right, ridges also. Okay, right. Then I can have a fault. What is a fault? See, fault is a stage before this crust completely opens up. Same thing, for example, if there is a land, right? Land, continental crust goes for a divergence, right? Somewhere it will be resulting in a fractured zone. Slight extension of the fracture zone, you call them as what, right? Say, for example, a fault zone or a rift valley. Only after forming a rift valley, I'll be having, say, for example, the mountains getting uplifted and somewhere going for a subsidence. Okay. So you may also have a fault line, fracture zone also you can have it. Okay. So here, I have, say, okay, somewhere I have just written San Andreas fault. Let's not bring this San Andreas fault because we'll be confining only to what? The oceanic regions. So somewhere very near to San Andreas fault, I can talk about the extension of it. Okay. Right. Or otherwise, my dear friends, to be very precise, to be on a safer side, what all I can write it, I'll tell you. Mid-oceanic grids. Okay, convergent boundary. Talk about trenches. Talk about island arc. If you want to include, you can also include volcanoes. Volcano. Okay. Somewhere, wherever the plate boundaries are there in the oceans, be it convergent or divergent, whatever it is that there, you may have what volcano. Convergent boundary. Andaman and Nicobar itself is an example of ocean-ocean convergence. I have Barren Island volcano. I have Narcondam volcano. Okay, right. Fine, my difference. Mid-oceanic ridge, we do have it. Okay, there also you find volcano. For example, Iceland itself is called as land of ice and fire because it is volcanic in formation. Okay, right. Right. So these are the features. If you write it, this should be more than enough. I repeat again. You write about trenches. You write about island arc. You write about mid-oceanic ridges. You write about volcano. If possible, you write about fracture zone or fault. But otherwise, the four features what I have given, that should be there. With examples, it has to be there. Okay. Right. Not all oceanic feature. I repeat again, oceanic feature along the plate boundaries I should talk about. Okay. Right. Now here, my dear friends, this question I have taken from the another paragraph of geography syllabus. It says, right, factors responsible for the location of primary, secondary, and tertiary sector industries in various parts of the world, including India. Okay, so this is that part of question. What I'm just somewhere I'm just taking it. Okay, now here, right, analyze the locational pattern and problems of cotton textile industries. Locational pattern and problems of cotton textile industries. Simple. First part, it talks about the locational pattern. Second part, they're asking you about the problems. They're asking you about the problems, right? Locational pattern as well as what? Problems. Both they are asking. Okay. Right, my dear friends. Having said this, right? Locational pattern and problems. First, we'll talk about the location, right? Location. Where all I'll be having cotton textile industry. See, when I talk about the factors responsible for the location of industries, various factors are there. Where you get a raw material, where exactly is the market, okay, the cost of land, the connectivity, the availability of the labor, uninterrupted power supplies, government subsidies, right? Even say, for example, weather and climate, n number of factors are there. But predominantly two factors. Where is the market? Where is the place you get the raw material? And it also depends on the type of the raw material. The raw material is somewhere weight losing. What is weight losing? At every stage of processing, if the weight of the raw material gets reduced, I call them as weight losing industry. For example, if I have 100 kgs of raw material, if the output is only 10 kgs, somewhere I understand it is weight losing. On the other hand, I also have a raw material. It's not a raw material, kind of an industry. You call them as assemblage industry. Every time it becomes heavier, 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 and heavier. See, there is actually speaking, you call them as a weight gaining industry, but very technically speaking, I cannot have weight gaining industry. It is more like assemblage industry. The product becomes heavier. Small, small parts will come together, it becomes heavier. Again, small, small parts, you join it with that, it becomes heavier. Again, it becomes heavier. Weight gaining industry. Now, see, industries are located in such a way where transportation becomes effective. It is easier and it is also cheaper. In that way, if a raw material is weight losing in nature, most of these raw materials are located near the place where you get the raw material itself. If it is weight gaining in nature, my dear friends, these raw materials are generally located in a place near the market itself. But if you ask me cotton, what type of raw material is cotton? Cotton belongs to pure raw material. Neither it loses weight nor it gains weight. Okay, if that is the case, wherever you want, you can have this cotton industry. You can have it near the market, or you can have it near the place where you get the raw material, or you can have it anywhere between the place of both this. Right? Between the places where you get the raw material and right. say for example, the market. Okay, it belongs to pure, right? Neither it loses the weight nor it gains the weight. Okay, so in that way, my dear friends, how to answer this question? Analyze the locational aspect. Give a brief introduction about the favorable geographical location of cotton, right? Growth in cotton industries. Okay, and the question is particularly they are asking about what? India. I should somewhere talk about India. Okay. Now here, if that is the case, my difference, what is the condition needed? Right? A good yield of cotton requires what all it needs: high temperature, light rainfall, 210 frost-free days. Right? It means cotton cannot be cultivated in a place where you experience what? Extended winters and plenty of sunlight. And what is very important? Black soil. So given even alluvial soils, it can be right grown. But when I talk about black soil is a default soil, a soil which is known for self-flowing mechanism, right? Default soil. Okay, when I talk about black soil, my dear friends, sometimes this black soil itself is called as what? Black cotton soil. The name of the soil itself, you call them as what? Black cotton soil, because it is known for what? Cotton cultivation, best suited for cotton. Okay, so given all the facts, right? Cotton are generally grown in Deccan Plateau. To be very, very precise, it is not even Deccan Plateau, it is Deccan Trap. To be very precise, Maharashtra, today's presence of Maharashtra and Gujarat. These are the places where the cotton growing tract in India is largely associated. Okay. As I already said about this, say for example, this cotton, I told you that cotton, there is neither loss nor gain in the net weight of the raw material. Means what? It is a pure raw material, right? Hence, the industry can be placed anywhere between the raw material and the market. That's what I said, right? Other factors like transportation, market, cheap labor, electricity, etc., are very, very important. Okay, right. So now comes the distribution. When I talk about distribution, Maharashtra, particularly when I talk about Mumbai, Mumbai is called as Cottonopolis of India. It's called as Cottonopolis of India, right? Sometimes, right? Even say, for example, okay, it's called as a Cottonopolis of India, and plenty of, say, for example, right, centers of cotton you have in Mumbai, right? One or two example you give it, that should be more than enough. Mumbai alone, you give it more than enough. Mumbai is a market, and Eastern Maharashtra is known for cotton growing tract. And Mumbai also has, say, for example, port where the cotton textile or the, say, for example, the finished product can be exported. Okay, right. Now then Gujarat, my difference. Gujarat is the second largest producer of cotton textile, right? Next only to Maharashtra. And how about, say, for example, Ahmedabad somewhere, right? You call them as what? Boston of the East. Okay, too many nicknames are there. Don't take this seriously. Mumbai alone, you take it. Okay, you call them as what? Boston of the East. Okay, right. Mumbai, Gujarat. Again, say, for example, what can be the reason, right? Cotton growing tract, market access, right? But still, I can understand Maharashtra, it is more. Mumbai, it is more because we call them as what? Geographical inertia, or you call them as what? Industrial inertia. Because Mumbai is the first place where the first successful cotton textile industry was established. So that is again a multiplier effect, or you call them as what? Industrial inertia. Okay, this is one of the very important reason why Mumbai flourished as a cotton textile industry. In Tamil Nadu, when I talk about Tamil Nadu, particularly when I talk about, say, for example, this Salem to Coimbatore belt, which also includes Tirupur, right, Erode, etc. Particularly when I talk about Coimbatore, Coimbatore is called as Manchester of the South. Okay. Then other areas are distributed, my dear friends. Okay. So three areas somewhere, if I'm just mentioning, Maharashtra, followed by Gujarat, followed by Tamil Nadu. All other areas, I can take it as a, say, for example, extended information. More than enough. Okay. See, what else you can add it? Somewhere they say, right, patterns, I have just taken it. But what we have not, or what I have not discussed in this question, I'll tell you, I have not discussed about the, okay, I have discussed, sorry, right, right. The second part of the question is problems of cotton textile industry in India. See, what can be the problem, I'll tell you. For example, first and foremost, Scarcity of raw cotton. To be very, very precise, there are three types of cotton that comes: long staple, medium staple, and short staple cotton. It depends on the length of the individual thread. Given the climatic condition and say for example, or I should say climatic condition in India, normally we do not say for example grow long staple. What we generally grow is what? Medium staple, and say for example we grow what? Short staple. Okay. We grow medium staple and short staple. Okay. Most of the time when I talk about long staple, this long staple cotton come from what? Right? We import it. The long staple cotton mostly we import it. Okay. So scarcity of the raw material is number one, because the length of the cotton threads determines the quality of the thread. Quality of the thread determines the yarn. Quality of the yarn. Quality of the yarn determines the quality of the, say for example, quality of what? Quality of the textile product itself. And number two, obsolete machineries. Right? We are not, say, for example, using the best of the modern machineries. Maharashtra, Gujarat is an exception because you have a port orientation. You have a port access, so you can import the modern machineries. But as you move away from the coastline, as you move towards the interior parts of the country, say for example, the machineries what we use, they are mostly obsolete. When talk about, say, for example, obsolete, my dear friends, they are, say, for example, almost outdated. Okay, they are largely outdated. Erratic power supply. We don't have, say, for example, that continuous power supply is largely same. And the textile industry's power, not only power, it should also be what? Cheap power. Okay, input cost. Power is an input cost. Low productivity of the labor, particularly when I talk about, say, for example, the trade union and others. See, I'm not saying that trade unions are not good, right? But somewhere, most of the time, the trade unions as such, somewhere, right, halt the process of the industries, right? Low productivity of the labor followed by the strikes, right? Competition, particularly when I talk about, say, for example, the competition, right, which comes particularly from outside countries, other countries, correct? Particularly China. Then we have large number of sick mills, my dear friends, where reconstruction becomes very, very challenging. Okay, so these are, we talked about the locational aspect, we talked about the problems. We can also add the land cost. Okay, that can also be a means problem, because sometimes what happens, everywhere you cannot start this industry, because cost of the land also matters a lot when it comes to setting up of an industry as such, right? Right, my dear friends. Now coming to this question number 7, very direct question. Delineate the coal fields of India and mention their distinctive features. See, okay, what I'll do, distinctive features, we'll take it. But when I talk about delineate the coal field, okay, what are the different types of coals we have in India? I'll tell you first. For example, when it comes to India, draw a map of India and mark coal field. If you can draw a map of India like that of India, you draw it. Otherwise, you leave it. Okay, at least approximately it should look like India. Practice. See, for example, I'm telling you, for normally we have tested, and somewhere it has, say for example, it has resulted also. Positive reinforcement we had it. That way, if you can draw a map of India like that map, like that of India itself, okay, nearly. If it is, say for example, more beautiful, right? I think, say for example, human element is always there in this examination, right? People get attracted, okay, and that also gives you confidence. So better you start practicing to draw the outline map of India. Not more than 10 seconds you should take it. 10 to 15 seconds you take it. Otherwise not, right, needed. More than that, it is not needed. Okay, right. Fine, my dear friends. Right. Fine. Then, for example, directly you discuss about the features of the coal field, right? In coming to coal of India, see, uh, classification of coal. The global classification of coal and Indian classification of coal is slightly different. Coal, global classification, we have coals like anthracite coal, right? Anthracite coal, bituminous coal, right? We have, say, for example, right, bituminous coal, then we have lignite, then we have peat. Peat is actually not a coal. Peat is coal in making. Am I right? So anthracite, bituminous, lignite, and peat. These are some of the type of coal. Highest coals, highest, say for example, category of coal is anthracite. Then comes bituminous coal, right? Slightly less, but still good quality of coal. Then comes lignite, right? More of, say for example, it is more like a gray coal. Am I right? Then peat. Peat is coal in making, I said. Right? This is global classification. But when I talk about Indian classification, we have two types of coal: Gondwana coal and tertiary. Normally, my difference is Gondwana coal mostly belongs to this bituminous coal, and tertiary coal is nothing but what? Lignite. Okay. We do not have anthracite coal. Very traces we have. Very small traces we have in the name of what? Anthracite coal. Okay. Peat I'm not even considering peat. Okay. So Gondwana coal is largely bituminous. Tertiary coal is what? Lignite. Okay. All right, my dear friends. Now we have to discuss about this Gondwana coal. See, for example, tertiary coal, only limited regions as such. Okay, only very limited. When I talk about Gondwana coal first, see, when I talk about, I have just given you this Gondwana coal, right? Both are there. Gondwana coal. When I talk about, say, for example, almost this region, Jharkhand, Madhya Pradesh, Chhattisgarh, Odisha, and West Bengal, right? This is one region where I have the largest continuous, say for example, amount of coal that is available. And of course, I have this Assam also, I have considerably the bituminous coal that is available. Okay, or I should not use this word called as bituminous. Say for example, I'll talk about, say for example, I'll put it as the Gondwana coal. I talk about, say for example, this lignite, my dear friends. Lignite, right? Lignite, say for example, largely we identify lignite, right? Of course, the default location comes in the name of what? Neyveli, Tamil Nadu, Gujarat, Rajasthan, and Jammu and Kashmir. These are the four major areas where you have this lignite. Okay. And when it comes to distribution of the coal, my dear friends, distribution of the coal, right? Jharkhand alone occupies somewhere around 29 percentage. Odisha 25 percentage. Chhattisgarh somewhere around 17 percentage, and West Bengal somewhere around 11 percentage. Okay. Now, somewhere what I understand, okay, nearly 80 percentage, more than 80 percentage, I should take it. Okay, more than 80 percentage of this coal in India belongs to these four states as such, right? Right. There's something like, say, for example, 3 plus, right, 4, 7, 82 percentage. If you add everything, it comes approximately, okay, more than 80. Okay, 82 percentage of coal is confined just to four states. That is Gondwana coal. Okay, so I have just given the reserve and character of Gondwana coal also somewhere you can write. You can pause it also and you can read it. Okay, so where all you have this major Gondwana coal fields in India, that also I have just given it. Okay, right. Tertiary coal, my dear friends, right? A short brief background about tertiary coal I have just given. And where all, say for example, you have this tertiary coal that also I have given, largely Tamil Nadu, Gujarat, Jammu and Kashmir, and Rajasthan. These are the four major regions where you have this tertiary coal or lignite. Okay, right, my dear friends. Okay, so tertiary coal mines also I have given. Right, peat. Some of the peat regions where you find the peat, that also I have somewhere I have given it. Okay, right. And just a piece of information. July 10th, we're also starting a batch on anthropology, right, for optional subject, exclusively for the students of Unacademy platforms. If you're interested, kindly use it. All right, my dear friends, this is one question that anybody with the larger common sense can answer. Why urban areas are more vulnerable to floods than that of a rural setup? Right? Suggest some effective measures to mitigate the urban flood. Number one, I have to say that why urban areas are more vulnerable to floods than that of a rural area. See, if you are there in NDMA site, once you read this NDMA site, they have given a ratio, 1:6 ratio. When talk about rural area versus urban area, the average rate of flooding from place to place it will differ. From city to city, this number will differ. But they say an urban area is at least 6 times more vulnerable than that of a rural area when it comes to flooding. Very as a layman, if I want to understand, very crude example, but just to understand, right? Normally, if I just talk about one average rural area versus average urban area, same amount of precipitation, same duration of time, right? Assuming that the water will rise for 1 feet in rural area, urban area, the water will rise for 6 feet. See, raising of 6 feet and all, it is questionable. Okay, I'm just giving you, right? How should I understand this ratio, right? The rate of increase of water. I call them as flooding. See, flooding, say for example, not necessarily flood happens only because of rain. N number of reasons are there. Okay. Now, somewhere first, I'm just giving you the comparison between urban area and urban flood and rural floods. Okay. According to NDMA's, say for example, analysis, one urban area is 6 times more vulnerable than that of rural areas. Now comes the question, what is the reason? See, for example, I'll take it this way. You have surface water. You have some surface water. What are the different ways that surface water will get removed if you ask me? Number one is evaporation. Number two is percolation. Percolation. Number three is surface runoff, reverse. You call them as what? Surface runoff. These are the three ways runoff. Call them as, okay, this is surface water. Lakes, rivers, ponds, all these things. Correct? Either it should get evaporated or it should get percolated or somewhere it should go for what? Surface runoff, reverse. Okay, it should be more like a reverse. Now here, what happens? When it is raining, evaporation will be very weak. Alright, it becomes very weak. Hardly I'll be having, say, for example, any evaporation taking place, negligible amount. If that is the case, how exactly the water is removed, if you ask me, majorly by surface runoff and partly by surface or subsurface movement or subsurface percolation. Majorly surface runoff. See, always understand my defense. If the rate of accumulation of water is more than the rate of removal of water, it will be resulting in flood. These are the different ways how exactly the water is removed, either evaporation or percolation or surface runoff. In rural areas versus urban areas, what is the difference? The surface runoff is highly stressed. There are n number of bottlenecks. Trespassing of the surface runoff is there. Number of bottlenecks. Am I right? Say, for example, the canals will be right. Storm water drains will be occupied, stress passed. Natural waterways will be stress passed, right? Say, for example, right, almost the blind development and say, for example, the illegal occupation and construction of the water bodies and swamps, right? N number of things, right? N number of water logging also you'll be having, bottlenecks you'll be having. Am I right? Even say, for example, right, somewhere irrational disposal of waste will also somewhere result in what? Disturbed surface runoff. How? Somewhere if it is all the waste, say for example, the plastic waste, the municipal waste, if at all if it is entering the storm water drain, it will start coagulating the movement of the water. In that way, say for example, it cannot, right, almost have a free flow of the water. And of course, city, urban areas, what is literally missing is what? Percolation. You have well cemented pavements. We have well, say for example, laid metal tar roads we have. Where exactly the water can have its seepage, percolation, that is affected. So urban areas, what is affected? Surface runoff is affected, percolation is affected. So I should say, what are the different ways that surface runoff is disturbed? Why exactly means why exactly the percolation is very minimal in what urban areas, right? The exposed surface or that part where you see the soil in an urban area itself is what? Very difficult. Very rarely you see it. Okay, right. Now Second part of the question is what mitigation. When talk about mitigation, my dear friends, very simple. You correct the problems, it becomes mitigated. When I say bottleneck, remove the bottlenecks. When I say trespassing, say for example, remove the illegal construction. All right, illegal construction. Okay, effective stormwater drain has to be there. All right, so somewhere that surface runoff is taken care. Percolation. I have say for example more of open areas. Right, you should have a concept of urban forestry. More of say for example OSR land has to be there so that say for example the water will start percolating. Okay, so most of the time, right, what you see, say for example, right, as a cause of the flood, you start correcting it, that becomes mitigation. See, mitigation, you know what is mitigation? Natural disasters cannot be prevented, but it can be mitigated. The effect of the disaster can be reduced. All the conscious effort you take in order to reduce the eventual impact of a disaster, you call them as what? Mitigation, right? Preparedness. Am I right? Even desiltation is a mitigation process. Correct? Okay. Right. Even say, for example, groundwater, say, for example, or rainwater harvesting is a mitigation technique. Rainwater harvesting, in the sense, you are creating more avenues for the water to percolate. Right. So, correct the cause, that becomes the right tool of a measure. So, right, my dear friends, these are some of the questions what I have taken for our discussion. Right. So, nearly, say, for example, we have taken it for 1 hour. Right. So, that brings the end of say for example this discussion, and rest of the question and some of the questions, right, we'll discuss in the classes to come. Right, so wishing you all the best, right, for your career and for the preparation. Thank you and God